A lambda expression is nothing but an anonymous method. That is a method that has no access modifier, like public or private. It has no name, and it has no return statement. Why do we use them? Why do we use anonymous methods? For convenience. We can write less code and achieve the same thing. Plus, our code would be more readable. Let me show you this with an example. Let's say we would like to write a method that takes a number and returns the square of that number. Typically, this is how we would do this. So static int square int number return number times number. So return the square of that number. Let's make a call to this method. So first I put console write line square, pass in 5 here. So we should get 25. Let's run the application with Control and F5. There you go. Now with Lambda expression, we can achieve the same thing, but with less code. Let me show you how it works. The syntax for a Lambda expression is something like this. So we have the arguments, then the Lambda operator, and some expression. Read this as args goes to some expression here. For example, if I want to rewrite this method using a Lambda expression, this is how I would do this. So the parameter or the argument is number, then goes to number times number. So this is what we call a Lambda expression. And this code is exactly equivalent to this method. And as you see, it's shorter. I didn't have to specify static, an access modifier like public, private, int as the return type or as the argument type. The compiler can automatically infer that in most cases. And if not, we can explicitly specify that. I also didn't have to write this return statement here. So what we need to do is we need to assign that to a delegate. Remember what a delegate is? A delegate is a pointer or reference to a method or a group of methods. In .NET, we have some built-in delegates that you see all the time. For example, we have func and action. Just to refresh your memory, let me comment out this bit. So func represents a method that takes 0 or more arguments and returns a value of type tResult, which is generic, as you can see here. Action, on the other side, is another delegate that takes 0 or more arguments and returns void. In this case, if you want to use a delegate to point to this method here, we need func. So we can say func of int and int. The first parameter here, the first generic parameter here, represents the argument to the method, and the second one represents the data type or the return value. So in this case, because our square method takes an integer and returns an integer, we use func of int and int. So let's give it a name. This delegate, as you see, can point to this method without any problems. Now, what I can do is, instead of creating that method here, I can just use a Lambda expression here, saying number goes to number times number. And I can call this delegate like this. Let's run the application. We got the exact same result, 25. So there's no need to write this method here. I can just get rid of it. With ReSharper, as you see, it's grayed out. So I can press Alt and Enter. And note, the first suggestion is remove unused method. So enter, gone. So this is the basic syntax for a Lambda expression. On the left side, we've got the arguments, the Lambda operator, and the expression. If we don't need any arguments, we need to write a Lambda expression like this. Goes to, and here's the code. If we have one argument, we can use just the argument by itself without using parentheses. And if you have multiple arguments, we should always surround them in parentheses. X, Y, and Z goes to blah, blah, blah. In terms of scope, the Lambda expression here has access to all the arguments passed as well as any variables defined inside the method here where we define the lambda expression. So let me show you an example. Let me delete this. I will create another one. Let me define a constant, call it factor, give it value of 5. I want to create a method that takes a number and multiplies that by this factor. So I can use funcDelegate. The input to that function would be an integer, and it returns an integer. I call this function or delegate multiplier, and I use a lambda expression to say n goes to n times factor. So as you see, we have no compile time error here. This lambda expression perfectly understands this factor constant that is defined here inside this method, as well as the argument that is passed to it. So let me call this multiplier, give it a value of 10. So we should get 50 in result. And I can put that on console. So CW, remember, code snippet, tab, result, and let's run the application. There you go, we got 50. So this is the basic of lambda expression. But let me show you a more practical and common use case of lambda expressions. First, let me get rid of everything here. We're going to work on another example. Here, I've got a class called book repository. Let's say this is responsible for returning the list of books from the database. Now, to keep things simple here, I have just hard-coded a few book objects in a list. So this method here, getBooks, returns a list of books, and list, as you see, it's a generic type, as indicated by angle brackets. So it's a collection of books. And here I'm using the object initializer syntax during initialization of the list, so I can immediately populate that list with a few objects. As I instantiate each book, again, I'm using the object initializer syntax to quickly initialize the book object. So we have 3 books, title 1, 2, 3. The first 2 are less than $10, as you see, and the second one is $17. Let's say we want to write a code that returns all the books that are cheaper than $10. So let me show you how we would typically do this without a lambda expression, and then we will refactor the code and use a lambda expression instead. So first, let's get the list of books. So at this point, our books variable is of type list of book. So here, as you see in the tooltip, it points to a list of T. And here, note that T is a lambda expressions.book. Lambda expressions is the name of my solution or project. So it's a namespace. Okay, now let's take a look at this object. See here in the list, we have these find methods here that are used for filtering collections. I'm going to show you how to use find all. Take a look at the argument. Here we need a predicate of type book. What is a predicate? You see that all the time when working with collections. A predicate is basically a delegate which points to a method that gets a book, in this case, because it's of type book, and returns a Boolean value specifying if a given condition was satisfied. Let me show you an example. So I'm going to create a predicate function. Let's call it is cheaper than $10. I pass a book here, and I return true if book.price is less than $10. So this is what we call a predicate method. It gets an object of type book and returns true if a given condition is satisfied. All these find methods here they accept a predicate. Look. So what happens when I call this method and pass a delegate of type predicate, which means a method like this, I can pass that here, is cheaper than $10. What happens is the code inside this method will iterate the collection, and for each book, it will pass that book to this method to determine if the condition is satisfied. If yes, then it will return that book in the list of results. So with that code, I can say cheap books equals to that. And let's iterate that collection. It should be cheap books. And let's put that on the console. So I'm going to display the title of the book. Let's run this application. So we got title 1 and title 2. And back to our book repository, note that both these are under $10. So the code is working. Now let's see how we can change this code and use a Lambda expression. See, the problem here is every time we want to call this find or any of its variations, we have to go and create a method like this. And while this is perfectly fine, we can achieve this with less code. So why not? So here, all we have to do is to say book goes to book.price is less than 10. So this Lambda expression is exactly equivalent to this method here. And with ReSharper installed in my Visual Studio, you can see that now this method is grayed out, which means it's not used. So what I can do is to put my cursor on the method name here, and we get this triangle here. I can press Alt and Enter, and the first suggestion is to remove unused method. So I press Enter, and that code is gone. So again, this is a Lambda expression. On the left, we've got the argument, and on the right side, we've got the actual expression. And this is what we call a Lambda operator. We read this expression like this. Book goes to book.price is less than $10. In C#, it's pretty common to use a single letter when defining Lambda expression arguments. So in this case, because we are working on books, it's obvious. So we can just use B. See, the code is even shorter now. Well, that's it for this video. I hope you enjoyed it, and thank you for watching.